Okay, so welcome everyone to our CCNA Introduction Networks class meeting for this week. You will have noticed on the schedule this week, there's nothing major for us to do this week, but we are starting on the single most important part of this entire class, and that is the IP addressing and the subnetting portion. So as we're working last week's and this week's, try to catch up, try to get everything together. I know you are probably behind, as I've noticed from grading that many of you are behind. I know just last week, most of you ended your classes, so let's try to get caught up if we can. And I know for a fact that you also need some downtime. So just try to get caught up as best you can, and we'll work together to get through all this material. I will be on, and technically I'm on faculty break. I know I guess I'm not, but I'm supposed to be on faculty break. But I will be here today and tomorrow. I will be out of the office Wednesday through Sunday, and we'll be back on Monday. I will be looking at emails, so if I will at least we'll check them, try to check them once a day. So if you have a major issue, you can catch up with me. But otherwise, I'm gonna try to take a little bit of break toward the end of this week, so I don't lose my entire faculty break. It's funny, we get personal leave here, and it seems like every single year I end up giving the school back free personal leave because I just don't have time to take it. So it's I'm trying to actually use my break this time. Any questions before I start talking about IPv4 addressing and logical addresses in general? Let me pull the chat up so I can see it. Yep, I'm gonna try. I am definitely gonna try. And we're gonna go up to Virginia Beach for a couple of days. I'm gonna go up. Those of you who are in Hampton, you know, I'm gonna go to Virginia Beach. My mother-in-law wanted to go to the beach, so we're gonna go up there and spend a couple of days this weekend. So I really like Virginia Beach. I call it a city with a beach instead of a beach city. So hopefully we'll go up there, eat at Tautog's, and spend a little time on the beach where it's cool. But I do appreciate that. I'm gonna try.
Kelly.
Yes.
Have you been to Hampton University?
I have not. I've never been to Hampton.
Okay. Well, let me check if I can invite you. We are close, but we would like to welcome you if possible. I'll talk to some people there, and
Okay.
if you like 1 hour, we are not far away from Virginia Beach.
Okay, let me know, and I'll see what I can do, because like I said, it'd be fun to come over if we could. Just let me know. Like I said, I know we'll travel. Travel day is Thursday, so probably the only day I would really have would be sometime on Friday.
Perfect.
But just let me know, and like I said, if it can't work out, that's fine. I'll come back. I usually come to Virginia Beach to teach for at Dam Neck for the Information Warfare Center there for the Navy. I usually end up teaching once or twice a year for them. But yeah, let me know, and I'll try to work it in, because that would be great. I'd love to see the university. Definitely would.
Thank you.
All right, so let's talk a little bit, folks, about layer 3 addressing or IPv4 addressing. I want to start out first off by just talking about IPv4. We know that these are logical addresses, so we know that they have nothing to do with the actual hardware on a computer or the hardware or anything about it. We also know that as logical addresses, they are 32-bit addresses. Okay, so they're 32 bits. And we also know that one of the key things that I want you to remember is this: an IPv4 address, for it to be assignable to a host, okay, for an IP to be a valid IPv4, so to be a valid IPv4, here's our rule. All right. The host bits cannot be all zeros, or all ones. And that's going to make a lot more sense here in just a second when I talk a little bit more about addresses. But just keep that in the back of your mind, because we're gonna use that as a main thing. So if I give you an IP address, by the way, let's just do 192.168.12.10, and I'm going to say /24. Now, it's very important that IP addresses always need a prefix for us to be able to determine whether or not they are valid. This /24 tells you the number of bits turned on in what is called the subnet mask. So if we were to write, sorry folks, my phone's ringing. If we were to write this subnet mask out in dotted decimal, this would be 255.255.255.0, which is, if you'll notice, 8 plus 8 plus 8, it's 24 bits. So /24 and this are exactly the same thing. IP addresses, okay, consist of a network portion, a host portion, and then an optional, what is called a subnetwork portion, okay? Now, this particular address does not have a subnet portion, and you'll learn why in a few minutes. But here, in a normal IP address, the subnet mask places a 1 in the network portion of the address. So if I look at this right here, this is telling me that this is on network 192.168.12.0. Okay, so that is the actual network. Okay, sorry, it seems like every time I get in class, somebody tries to call. And then wherever there's a 0 in the mask, where the zeros are, that's the host portion. So in this particular address, this is host number 10. So we've got a network portion and a host portion. And the only way we can know what part is what is by looking at a prefix or a mask associated with that address. Very, very important, because I can go and say, all right, let's do this. I'm gonna go ahead and go back. Oops, it's picking up my thing here. I'm gonna go back here a second. Create a new one. So if I go here and I go, okay, how about the address 10.0.0.1/24? All right. Well, you're going to learn something here in just a minute. In fact, let me go ahead and show you that, because it's important for you to know that the curriculum teaches you this, but it doesn't really start out with it the way I like to do it. I like to introduce my students first to what was called classful addressing. So back in the beginning of when the internet was around, we used classful addresses, which means we had a class A address. And in the class A, the first octet in binary started with a 0, okay? The first octet in decimal was from 0 to 127, okay? In fact, I didn't need this range here. Let me get rid of that, because that's actually my range. Okay, 0 to 127. And the default mask was 255.0.0.0 or a /8. Okay, now this was a small number of networks that consisted of a very large number of hosts. You'll notice there are 24 host bits here and only 8 network bits. And in fact, there's really only 7 network bits, because the first octet has to have a 0 in the leading position. Now think about this. How do we get the fact that the first octet has to be 0 to 127? The reason we do that is because if we do all zeros, 2, 3, 4, 5, 6, 7, 8, that equals 0, obviously. And we can go all the way up to 0, 1, 2, 3, 4, 5, 6, 7, 8, which is 127. The second there's a 1 in the beginning at that first octet position, it goes over 120 up to 128. And that's where we get our breakdown for our class Bs. Okay, so let's do this. Let's take rid of that. I don't know why it's not getting rid of that. Let me get rid of it. I get rid of my zeros. It's not wanting me to do it that way with the pen, so we'll do it like this. Okay, so now we also had what is called a class B. I got it. I got my eraser. You understand? And in a class B, the first octet has to have a 1, 0 at the beginning, and that is 128. 128. Golly, I'm drawing a blank, folks. 192, 190, 191. Oh. Whoa, wait a minute. Hold on, let me just do this. I'll go here. Let's go to right here. It's easier. I'm not writing good today, folks. My hands aren't working great. So let's look right here. So we've got a class A, which is 0 to 127. We got a class B is 128 to 191, and class C, which is 192 to 223. The big thing about these classes is you will notice there was a large, as we look here, these are, golly, I don't know why it's doing that. Hold on. There's a large network right here. Okay. One network of a large number of hosts. It's 16 million hosts because it's 2 to the 24th minus 2. This is 128. I have no idea why it's doing that. Maybe that. Okay, I'm gonna have to abandon this, folks. To 191, all right, which is a default mask of 255.255.0.0/16. And then class C, which had 110, which was 192 to 223, which is 255 with a default mask of 255.255.0/24 for a default mask. Then we had D's, which were 1110, which is 224 to 239. And this was for multicast. This was set aside for multicast back in the old days. And then there was actually an E, which was 11110, which was 240 to 255. And this was set aside for experimental use. Okay. So they took and broke down all the addresses that we have. They broke them down into these classes. Due to classful addressing, every single host on the network would have to have the same mask. So it was assumed, if back in the old days, it was assumed if you saw a 192.168.12 address, whatever it happened to be, 23 or whatever, it was assumed it would have the classful mask of /24, okay, because it's a class C. If it was an A, if you had a 10.0.0.1/8 is what would be expected. So I want to go back just a second. So that's a class A, which is one network of 16 million hosts. Class B was 2 to the 16th, really 2 to the 14th, because the first 2 bits are reserved had to be 1 zeros. 2 to the 14th number of networks of 2 to the 16th number of hosts, which so it's a balance. It's a decent number of networks and a decent number of hosts on each network. And then a class C, which was a large number of networks with only 254 usable hosts, because we've only got 8 host bits left. So when I go back to my example here and I show you this, assuming classful addressing like we do, we know that with this mask, this would be the network portion, okay? So we would know this would be the network portion. Down here now, we know that this, because it's longer than the classful mask, this is the subnetwork. So that's the subnetwork portion. And then finally, last but not least, this last 8 bits, this 1 is our host portion. So we've got all 3 portions in this address right here. And we know that because if it's a 10, we know that that is from 0 to 127, which is a class A. What is a famous class A address that's reserved for loopback? Anybody tell me? What's the reserved class A for loopback?
Is it 127.0.0.1?
That is correct. 127.0.0.1. If you ping that address, you're pinging your local IP stack to see if it's actually installed. If you get a response, it means at least IP is loaded and running on your machine. Doesn't necessarily mean you have an IP address. It just means that that's actually loaded and running. So that's called the loopback address. That is a class A technically. Okay, so they actually took an entire class A address scheme and set it aside to be loopback, which is a little bit crazy. But now let's look at this. Let's take 172.16.10.10. If we were going to be classful, what would be the slash notation for this network? If we were using classful subnetting or classful networking.
/16.
/16, correct, because we know this is, if we go back to our example over here, back over here. We know that if it falls in the decimal range of 128 to 191, also beginning with 10, and mathematically I could show you that 1 and 7 zeros is 128, 10 and 6 ones is 191. So that's how they got these ranges. If you ever wondered where these ranges came from, it's just the mathematical computation of the octet. So if it falls between 128 and 191, then we know it is a class B, and by default, it would have a /16, which would mean that in this world, this would be right here would be the network. Oops. Like I said, my hands are not working well today, folks. This would be the network. And then the host portion would be right here. I meant to change colors, but I didn't. So this is the host. This is the network. So let me ask you a question. Let me ask you a question here. If I tried to take and put the address 172.16.1.0/16 onto a host, would that be a valid IP address that could be assigned to a host? Jacob, Vince, anybody, let me know. Do you think it would be Glenda?
Probably not.
Would this be a valid IP address to assign to a host? Could I assign this to a Windows box or a Linux box?
No.
Okay, I got
I'm
one
gonna say
node.
no.
I got another node. All right, let's look at it. Okay, let's look at it. The definition that I told you is that all the host bits cannot be ones and all the host
That's
bits
yes. I'm sorry.
cannot be zeros. So who just said yes? Who was that that said yes?
Me. I said no at first, but it is yes.
It's a yes. It is yes, because let's look at this. We've got 16 host bits, right? Right here. Now those host bits are 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Okay, are they all ones? Nope. Are they all zeros? Nope. That is a valid IP address. Now it looks weird. It does look weird, but that's a valid IP address. Now watch this though. Let's change this. Let's do this. Now the second I do this, your answer should change. Now, the answer is that is not a valid IP address because, okay, we know this is our network portion, okay, because this is a class B. So here's our network. We have borrowed 8 bits to create a subnet. So here's our subnet. And then right here in our host portion, our 8 bits, they're all zeros. So that is now not a valid IP address. In fact, if you tried to assign it to a host, it will bark at you and say invalid IP address. It won't let you do it. So it's important. If someone hands you an address and says, okay, is this a usable address? My answer is, I don't know. Okay. If it's classful, if you say, is this a usable address, and they say using classful addressing, my answer is yes, that is a usable address because classful addressing would be /8. So I can go in here and say, this is the network portion. All right. And then this is the host portion. And the host bits, all 16 of those bits, all 24 of those bits are not zeros and they're not all ones. But if I don't have this /8, I have no idea to know whether or not that is a usable address or not. Does that make sense? All right. So that yay, nay, have no clue, still hoping. Well, here's how they show you the same thing here, folks. They show you the network and the host portion. They're just doing it right here. But the thing is, the only way to know what portion is the network and what portion is the host is by looking at the subnet mask. Okay, without the subnet mask, you don't know, because that mask puts a 1 in the network or subnetwork portion and a 0 in the host portion of the address. So as we go down here and look at the subnet mask again, This is a /24 because there's 24 ones turned on in that mask. And then by doing this, you can now see that this is a valid IP address because the 192.168.10 is the network portion and the host portion is the .10. And that is how we get what is called our prefix length. It's by the number of ones in the subnet mask. So if you ever wonder where that came from, that is exactly where it came from. It's just the number of ones in the mask. Questions about that? Okay.
Kelly, do all the systems use the binary system only, or is there other system that?
With IPv4, it uses binary. And with IPv6, it still uses binary, but it displays it in hexadecimal. So the computer itself is going to use binary regardless. Yes. So the computer's always using binary. It may display it to you in dotted decimal or display it in hex, but the computer is always binary, ones and zeros. Now, one of the things that we do need to know about is a logical term called ANDing. And so ANDing is one of the 3 Boolean operations. And basically it comes down to the only thing that gives you a 1 is a 1 and a 1. So and this is not the correct way to teach this. It's not mathematically true. So if you're math majors, you're going to cringe when I say this. But I teach my students, it's basically like you're multiplying the divide or the numbers to get your answer. 1 and a 1 is a 1. Everything else is 0 because ones and zeros. That's not, I know that's not what it really is. So, you know, just, I know it's Boolean logic, digital logic, but it works out that way. So, but what you do is, and this is very important, remember back, well, just last week, we talked about the process that a host has to do in order to send something to a remote destination. Okay. So if a host needs to send something to a remote server, the first thing a host has to do is it must determine what network am I sitting on. So what the host will do is it will take its IP address, in this case 192.168.10.10 again. It will take the mask that it is assigned on that particular interface and will perform an ANDing operation. And what falls through, you notice, will be just the network portion of the address. So through the process of ANDing, hosts determine what network they are on. They would then take the remote IP address or whatever IP address they're sending to, and they AND that remote address or the destination IP address to their mask, to the mask of the sending host, to see if that host happens to be on the same network as the sending host. If it is on the same network, it sends an ARP request, gets an ARP reply, builds a frame, sends it out. If it's not on the same network, it still sends an ARP request, but that ARP request, remember, is answered via the router by a proxy ARP. All right. So this process takes place every time a host sends something to a remote machine. In fact, it's used to build the local route table, and then it does route table lookups. So very important. It's also how, if I hand you an IP address 10.1.1.1/24, and I ask you what network is this on, the way to figure out whatever network an IP address is on is you convert it to binary. So 128.64.32.16. 8, 4, 2, there's 10. 1, 2, 3, 4, 5, 6, 7, 8. I wish I had $100 for every time I've written out 2, 4, 5, 6, 7, 8. A 1 or a 0. 1, 2, 3, 4, 5, 6, 7, 8. Okay. Then we put in our mask, which is 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. We perform the ANDing process, and what drops through is going to be the network this particular host is on, which you're going to learn is 10.1.1.1.0. So the host is on the 10.1.1.0 network. Now, you will know a little bit later from now, you'll realize or know that this is actually the 10 network, and then it's on what is called 1.1 subnet, okay? But be aware, because of this is how we find from any IP address what network it actually is on, is by ANDing it to the mask that is associated with that address. Questions about that? Because that's what the host is doing. Every host does that to determine what network it's on. So we have network addresses. And by the way, look at this. I want to show you this. What is in the network or the host portion of a network address? You'll see it's, this address is 10.1.1.0. So you'll notice if it's a network address, there are zeros in the host portion. You'll notice if it's a broadcast address, okay, if it's a broadcast address, all ones are in the host portion. And if it's in between, in other words, it's not all zeros and it's not all ones, it's a valid host address. So we can see here, these are all valid addresses. 1, 10, 55, 101, and 12 are valid addresses. The network address, though, is 10.0 because it has all zeros in the host portion of the address. The broadcast address for this subnet, if this router sent something to 192.168.10.255, every machine on this network would have to look at it because that is the broadcast address for that network. So we've got our network address, all zeros in the host portion. We've got our first usable address where it's not all ones or all zeros, our last usable address, and then our broadcast address. So every IPv4 network has a network address, a range, and a broadcast address. Okay, does that make sense? This is a little ANDing. You can do ANDing to go through here and see what networks fall through. And so it allows you, this is actually using subnetted. So we'll keep going through here and talk about more of that as we move down. But so here's a unicast address. Obviously, a unicast is from 1 to 1. So the source is 4.1, the destination is 4.253, which is this printer. So it would be sent only directly to that particular host. So 4.1 to 4.253. A broadcast would be either destination of all ones, or if you wanted to do it just to this one network, you could do 4.255. But in this case, it sent it out to the broadcast address, which means it goes to everybody. Now, remember, routers stop broadcast. So by default, it won't pass a router. So even though a broadcast goes to a router, that router will drop that particular packet. And the last but not least is multicast, and that's in that 239 to 240, or excuse me, 224 to 239 range. That gets us our multicast address, and that's 1 to some. So you join a multicast group, and one of the things that you can actually do, and I know the switch here in this example is showing multicast going to everybody. Cisco switches and modern switches have a thing called Igmp Snooping, or excuse me, Igmp Internet Group Messaging Multicast Protocol, but you can actually set it up to where if there's no multicast host on a link, it will not send it out. It'll actually just block it and not send it out, because it's kind of a waste here with this. That multicast goes out every interface and then gets dropped by the machines that are not part of that multicast group. So modern switches have the ability to block those and not allow them to go through. So that's our 3 main types of addresses. And then you may have heard of this before. This is the whole reason we're not already using nothing but IPv6. These are RFC 1918 addresses. And I pick on my students and say, you know, you need to know that you're at a dinner party and someone walks up and says, hey, do you know the RFC 1918 addresses? I said, you need to be able to go, yes, in fact, I do. And what they did is they set aside the 10 network, 10.0.0.0/8, to be that entire large class A to be used as what is called private addresses, 172.16 to 172.31. and then 192.168.0.0/16, so all the way up to here. These are non-routable on the internet. They will not go across the internet. They will be blocked by all ISPs. So they are private addresses, not for public use. There's another range. How many of you have heard of a PIPA? You know what a PIPA is? Anybody ever heard of a PIPA? When it first came out, nobody knew it was even going to be implemented, but it's automatic private IP addressing. It was come out first in Windows, I think it was Windows 95 that may have came out in, maybe it's Windows 7. But with a PIPA, remember we got 169.254.0.0/16, which is a range that Microsoft set aside. If you boot a Windows box and that they do not find a DHCP server, but they're set to DHCP, they'll give themselves an IP address in the 169.254.0.0/16 network. So while that's not an RFC 1918 address, it really ends up being a private address scheme because of the way it's been set aside by Microsoft. These are RFC 1918. They are blocked by all internet service providers. They will not allow those addresses to go across their networks. Now, unfortunately, in some parts of the world, we have had so many different devices using IPv4 addresses that we're having devices natted and natted and natted. And so there are some ISPs that are running private addresses inside of their core or inside of their network, and then eventually natting it before they send it out to the internet. But these addresses cannot be sent directly to the internet. We use the 10 network here at Stanley. Probably most places use the 10 because it's just very simple. You can subnet it however you want, and it's a huge address space. Okay. Here's the loopback 127.0.0.0. So we know that we can ping that, and if we get a reply, it means TCP/IP is loaded on your machine and running. And then these are called link local addresses, or a PIPA, automatic private IP addresses. And these are the ones that have been set aside by Microsoft if there's no DHCP addresses. I think they've even started being used by non-Microsoft devices. Questions about that? Here we are looking at our legacy classful addressing. By the way, the reason classful addressing was implemented is because our early routing protocols could not carry subnet mask information in the route table updates. So everything had to assume that you had the same mask across your entire environment. Otherwise, it would not work. So that's why we had classful addressing back in the day. However, you're going to learn how big of a problem that is here in a few minutes. So we had registries that put out or actually gave out public IPv4 addresses. They're all gone. There are no public IPv4 addresses. At one time, we actually had a class B address here on campus. We actually owned our own class B address, and our ISP came back and asked for it back. And I told them, don't give it back. But they did. And it was the right thing to do eventually. But that was nice back when we had our own full public class B. That was a long time ago, though. All right. So this basically is just asking you, is this private or public? You go through and make the decision. You're private, private, public, and then so on and so forth. Public, private, private, and private. I believe I got that right. Oh, got one wrong. Which one did I get wrong? 116, 168. Oh, right there. That's public. Okay, I had that one wrong. It's 192.0 is a public address. It's just 192.168. So kind of a neat little thing there. Now, let's think about something. I want to show you, let's imagine, okay, I want to show you a network. Let's look at just a basic network. So we've got a router here. And on this side, I've got a switch with one PC. He's a happy little PC. Okay. On this side, I got a switch. And he's a happy little PC. By the way, I was looking at, for some reason, I got to looking at something about Bob Ross. You know, it's extremely expensive to get one of his, actually one of his paintings, even though he created thousands and thousands of paintings, because so many of them, so few of them were actually sold or are on the market. If you don't know who Bob Ross is, he's the painter who used to have the painting show where he always painted happy little trees. But let me give you an IP address. I'm going to give you 192.168.12.0/24. All right. What class of address is this, everybody? You can put it in chat. Dr. Webb, Dr. Evans, anybody? What is this? What class of address is this? Okay. Look at the beginning, and you're looking at the prefix. Looking at the prefix. Lonnie, look at the actual first octet, the value. Ah, there you go. Yep, it's a class C. So this is a class C, which means it has 24 bits that are network. Okay, so this is our network portion. And then it has right here 8 bits that are hosts. All right. So we've got a little problem though. Okay, because this network needs one network here, and it needs another network over here, because every interface on a router has to be on a separate network. But my ISP only gave me this. They didn't give me 2 networks. They gave me 1 network. Well, now we have to do what is called subnetting. And I did actually put a video up, folks. Now it's an old video. You can see it's back before I am as old as I am now. It's actually, I think it was almost 14 years old. But in subnetting is the process of borrowing, this is the definition, borrowing host bits to increase the number of network bits. Okay. Now, there's the way the curriculum teaches you. I'm going to show you what the curriculum shows you. Then I'm going to talk to you about the 7 holy steps of subnetting. Okay. The curriculum shows you all of this, how you can break networks down into smaller networks. And so, but every single interface on a router must be its own network. So segmentation is done to, 1, reduce the amount of broadcasts on a network, reduce the amount, well, it used to be done to reduce the possibility of collisions. Collisions aren't as big a deal anymore, but it is to make the broadcast domains smaller. Makes more of them, but smaller ones. So what we're going to want to do is we're going to want to subnet that network that I just gave you so that it will match what we need. Now, we can subnet on an octet boundary. So if we could actually subnet with a /8/16 or /24. So we could take a 10.0.0.0/8 and borrow 8 bits. Okay, so we're borrowing 8 bits here. So those used to be host bits. Now they're network bits. And if we borrow them, we get this range. Now, this is how the curriculum teaches subnetting. And I don't think it works. I'll be quite honest with you. I think it's that at this point, you actually need to stop with the curriculum and teach them classful subnetting. Okay. Now, to do that, I do have a method. It's called the 7 holy steps of subnetting. I actually have that in one of the books I published, but it's not copyright or anything. I mean, it's mathematical, so there's nothing crazy about it that you need to know. But we know back here, let's look back on our page. We know we need in this network, we need at least 2 subnets. Okay, So step one in the 7 holy steps, step one is determine the number of subnets you need. So we need 2 subnets. Okay. Step 2 in the 7 holy steps is write out your host bits. Now that depends on what you've been given. So we've been given 192.168.12.0/24. Okay. And so we're going to write out the host bits. Now, the reason I have students do this, especially to begin with, is because I want them to realize the definition of what we're doing here. 1, 2, 3, 4, 5, 6, 7, 8. We are borrowing host bits to increase the number of network bits. Okay, so I have them write those bits out so they can see them. Step 3, we need to determine the number of bits we need to borrow to get the needed number of subnets. That is the formula 2 to the n equals number of subnets. Okay, and n equals number of borrowed bits. So what power do I need to raise 2 to get 2 subnets? Anybody?
1.
1. So 2 to the first power equals 2. So in step 4, we go back up to our numbers from step 2, turn on the number of bits we borrowed, 2, 3, 4, 5, 6, 7, 8, and then get the decimal value at that point, which is, what is the decimal value of that octet? Anybody? If I convert this to decimal, what would it be?
That's 255.
Nope.
No, that's 256. I'm sorry.
No, look at this now. We've got just only the first bit positions turned on.
Oh.
So we use our addition method. So if the first bit position is turned on, remember the first position is 2 to the 7th. So it's 1. This is 128. Okay, remember, let's go back and we'll review that real quick. Let me do this. This is 2 to the 0, 2 to the 1, 2 to the 2.
And miscounted.
Yeah, you just did it backwards. 2 to the 4, 2 to the 5, 2 to the 6, 2 to the 7. So this is the 128 position, 64, 32, 16, 8, 4, 2, and 1. So we've got just this 128 position turned on. Step 5 is add the value from step 4 to the previous subnet mask. So we know our mask used to be, our mask before was 255.255.255.0, right? Our new mask is 255.255.255.128 because we borrowed 1 bit, right? Now we're going to find our variable, okay? We got to find the variable for every single one of our octets. And by that, you go up and find the highest order bit turned on and find the value there. And so we find out that our variable is 128. And then in step 7, we can get our subnet ranges by using the variable. And so we start with our major network number. 0. Now, because I'm working just in the 4th octet, I'm not going to go anywhere else. But it's 0 to 127, which, by the way, that's 128 positions because we count the 0 as a position. So 0 to 127, and then my next subnet would be 128 all the way out to 255. Okay. So what you will notice I have done, okay, is I took and borrowed 1 bit from the host portion of this network, which was before this was 1 Class C network of 254 usable hosts. I borrowed 1 bit from it, and I have now subnetted it into 2 subnets. And what you're going to learn is every time you subnet, you reduce the number of hosts on those networks, because the formula to determine the number of hosts on any network is 2 to the H minus 2 equals number of hosts in a network. Okay, so let's look at this. Right here, we had 2 to the 8 minus 2, which equals 254. So this was 254 hosts in that network. Now we've only got 7 host bits left after we borrowed 1. So for this subnet, it's 2 to the 7th minus 2, which you're going to learn is 126 hosts per subnet. Now, somebody tell me, why did I lose 2? Anybody know why we lost 2 addresses? And every time we subnet, we lose 2.
The gateway in your broadcast address.
Okay, not the gateway, it's the network address and
It's
the
not
and the
valid,
broadcast.
not a
Exactly.
valid host IP address.
Exactly. So right here, we lose the 0 because all host bits are zeros there. We lose 127 because that's the broadcast for that subnet. So that's all ones in the host portion. So this subnet has a valid range of .1 to 126. Okay, so we lose the first and the last. So that's why we've only got 126 usable addresses, even though there's 128 spaces here. There's 128 numbers from 0 to 127, but we lose the first because it's the subnet ID. We lose the last because it's the subnet broadcast ID.
Kelly, can you do steps 4 through 7 again, if you don't mind?
I will, I'll do another example too. Let me do this real quick though. Let me back up over to our network, because with these 2 subnets, what I would do is I would assign right here the address 192.168.12.1/25, because remember, that's our new subnet mask right there. I could give 12.2/25 to here. Now, granted, it's still 192.168. Let me write that 192.168. Okay, and then this could be 192.168.12.10 or 12 whatever /25. Then over here, we go back to our subnet, and in this subnet, the second subnet, our first usable address is .129. So we would just assign that right here. So this would be 192.168.12.129/25. So we had one network of 254 hosts. We borrowed 1 bit, subnetted into 2 networks or 2 subnets of 126 hosts. Okay, so let me go back and I'll do this again. And also let me do this for you. Give me 1 second, folks, and I'll pull something up here. And I'll post the 7 holy steps of subnetting into the class too. Although they're they're actually already in the video I sent you. Okay. All right, so let's do this. Let's take same thing. Let's do 192.168.12.0/24. Okay, and let's say instead of, now remember, step 1 was determine the number of subnets you need. Okay, I'm going to say we need 3 subnets. Okay, so I'm just going to say 3 subnets. So I'm increasing the number of subnets we need. Now that would depend upon it. Sometimes it's just given to you. Sometimes you need to look at the network and make a decision based upon the network itself. But it is important that you are able to know that every interface on a router needs to have its own network. Okay. And folks, believe it or not, I cannot for the life of me find, there it is. Finally found it. So we're going to determine the needed number of subnets. Step 1. Step 2, we're going to write out our host bits. So we got step 2. We know we're still looking at this same class C, so we still only have 8 host bits. 2, 3, 4, 5, 6, 7, 8. Step 3. By the way, I've worked in this business long enough. I used to have 2 to the n minus 2 when we couldn't use the subnets of all zeros or all ones. We can now though. But step 3 is determine the number of bits you must borrow in order to get the needed number of subnets. Now, to get at least 3, now that's the key. We're not going to be able to do it exactly with just 3 subnets. But what power do we raise 2 to get at least 3 subnets?
7.
2 to the second power, which would give us 4, right? So we're going to have 4 subnets. Now that's 1 more than we need, but there's no way to subnet for just 3 subnets. Mathematically, you can't do that. All right. Step 4. Okay. Step 4, we look at, and this is very important. Let me pull the document back up so you can see it here. Turn on or set to 1s the number of bits you must borrow from step 3 and find the decimal value in octets of the octet. So we notice right here, we borrowed 2 bits. So look at step 2 and in your host bits, turn on 2 bits and then write out the rest. They're still host bits. Find the decimal value, which in this case is 192, because remember that's 128 plus 64, which is 192. Step 5, we find our new mask. So we figure out the new subnet mask for these subnets we're making by adding the decimal value from step 4 to the default mask. So our default mask used to be, or was before we subnetted, 255.255.255.0, but now our new mask for these subnets we're creating is 255.255.255.192. Step 6, we're going to find our variable. So we're going to find the value of the least high order bit turned on in the octet. So in step 6, we go back to step 4 and we look and find the last one turned on. We find the value at that position. And that's going to be our variable for our octets. And the variable, what is the variable in this case? What is the value right here? To get that, we got to go back over here, folks. We got to go back right here and see that the value at that bit position is 64. It's 2 to the 6th. Okay. So our variable, if we borrow 2 bits, is going to be 64. We now can write our subnets. In step 7, write down the major network address first, 192.168.12.0. That's what we had started out with, but now we've subnetted. So now our variable for each one of these is 64. So 0 to 63, 64 to 127, 128 to 191, and then 192 to 255. So by borrowing 2 bits, we took this major network of 254 hosts and broke it into 4 subnets. Now, how many hosts are there per subnet? Can anybody tell me? First off, what's the formula? Go ahead. Who was going to say it? The formula is 2 to the h minus 2 equals the number of usable hosts. Okay.
6.
So it's 2 to the 6th minus 2, which would be what? 62, right? 62 usable hosts? Makes sense, right? You also notice it's typically just the variable -2, but that only works with if you're in the 4th octet. Now this is classful addressing. In other words, I'm assuming that everybody's going to use this new mask. What's the slash notation of this new mask, by the way? Anybody? Just count the ones.
/22.
You went the wrong way.
One way.
Go the other way.
Be 26 then.
Bingo, exactly. /26, because you got 8, 8, and 8, which is 24 plus 2. So this is the same as /26.
I got you.
Now the 7 holy steps works for classful addressing. It works every single time. Now here's how the curriculum teaches it, which is it's fine and it works. What the curriculum tries to teach you to do is just look at borrowing using with a slash notation. So what they say is they want you just to learn, if you borrow 1 bit, okay, the new mask is 128, your variable is 120, your variable is 128, and that's how you break it apart. It's by 128, which you can do that. And by the way, it's also easy to do it like this. Let's imagine I can sit here and say, okay, I've got the address 192.168.12.0. This is /24. Well, if I go to /25, I know the variable there is 128. So I sit here and go 0 to 127 and 128 to 255. All right. Then if I go to /26, all right, I know the variable is 64. So I can break this down to 0 to 63, 64 to 127. And I know one of the things I want you to notice here, folks, I'm not making numbers up. I'm just taking these and breaking the subnets down into smaller subnets. And then we could keep going, /27. The variable is 32 here. So now you're at 0 to 31 and 32 to 63 and so on and so forth, all the way down. That's how the curriculum teaches it. I like the 7 holy steps because it will work even when you cross bit boundaries. It's a little bit more difficult when you cross bit boundaries, and I'll talk about that next time we meet. But it is important that you notice the way the curriculum teaches it is with this thing called the magic number. So they're basically saying my variable that I use in the 7 holy steps of subnetting is what they call their magic number. So if you borrow 1 bit, the magic number is 128. If you borrow 2 bits, the magic number is 64. If you borrow 3 bits, it's 32, 16, 8, and 4. All right. Now, the important thing to note is you can never borrow more than 30. You can never have more than a /30. And here's the reason. Remember our formula for host bits? 2 to the h minus 2. Well, if you don't leave at least 2 host bits, you get 0 usable host bits. So 2 to the 2 is 4. 4 minus 2 is 2. So you'll never see anything more than /30 being used for subnetting. Now, you may see an address assigned with a /32, but that means that one address is assigned to an interface. That's a very special case instance. All right. This is the most important chapter and the most important thing that you learn in all of CCNA 1. We are going to do a large number of examples. I'm going to post this into your class up at the top. So I'll put the 7 holy steps in the top. I want to give you a couple things I want you to try. Okay. I want you to do the following. I want you to take 192.168.12.0/24 and subnet it for 10 subnets using the 7 holy steps. I want you to do this for next week. Okay. Do it for 10 subnets and let's do it for 30 subnets. Then I want you to try this. This one's a little bit harder. 10.0.0, 0.0/8. And I want you to do this for 500 subnets. By the way, 7 holy steps will work on all 3 of these. All right, they'll work for all 3. let's do this real quick. I know we're over a little bit, but I want to do this real quick. Let's do the 10 subnet example together. So let's do that one real quickly. So step one. We know we need 10 subnets. Okay. We know we've got 192.168.12.0/24 is our starting network. Step two, write out our host bits. Now, by the way, when you get to where you really know what you're doing, you don't necessarily have to write these host bits out. I have my students do it because it really helps them to see you're borrowing host bits to increase the number of network bits. Step three, what power do I need to raise 2 to in order to get at least 10 subnets? By the way, when I go to take a certification exam, one of the things I do before I ever click start is I write this down the side of my sheet. If you've ever taken certification exams, you know that you have a little bit of time before you click start, especially if you're not doing it online. That's why I don't really like the online ones now. But this gives you 2 to the 0 is 1, 2, 4, 8. This is just so I don't make dumb mistakes.
32.
I mean, it's so easy to get in the heat of the moment and make a dumb
128.
mistake. Yeah.
256.
And then you got 512
What's 12?
and 1024.
That's 12.
All right. So what power do I need to raise 2 to in order to get at least 10 subnets?
1, 2, 3, 4, 5, 6.
2 to the 4th, right?
4. Yeah.
Which would give me 16 subnets. Now that's more than the 10, but I can't do 2 to the 3 because that only gives me 8. So now in step 4, let's return to our host bits and turn on the number of bits we borrow. So 1, 2, 3, 4, 5, 6, 7, 8. Get the value there. This is 240. By the way I know that is because if it's 1 and all zeros, it's 128. If it's 1, 1 and all zeros, it's 192. If it's 1, 1, 1 and all zeros, 224. 1, 1, 1, 1, 240. So I taught you that back when we were looking at IP addressing. Step 5 is to find my new mask, which is 255.255.240. Step 6 is to find my variable. So what I do is I go up here and find the highest order bit turned on, and the value there, which would be 128, 64, 32, 16. So my variable equals 16. Now I can get my subnet ranges in step 7 by taking the major network number 192.168.12.0 and then to 15, 16 to 31, 32 to 47. I'm not going to write them all out, folks, because I'd be writing for days. So just write them out to basically where you can get out here, and then that shows you, and that is breaking it down into 16 different subnets. How many hosts are on each subnet?
16.
Very close. 14. Well, you're right. 16 hosts. How many usable hosts? 14. Good answer. You actually are correct. Remember, it's 2 to the h minus 2 equals the number of usable hosts. But you are correct. There's actually 16 host addresses, 16 addresses, but only 14 are usable. So it's 2 to the 4 minus 2 equals 14 usable. And you can see that right here because the 0 is the subnet, the 15 is the subnet broadcast. So usable is .1 to .14. That is classful addressing. And that's using the 7 holy steps right here. You can use this. You can use your own method. By the way, one of the things I had to do is I just had to sit and just subnet and subnet and subnet till I got to where I could do it and was comfortable with it. Now, real world, I'm still going to check myself with a subnet calculator and make sure I don't mess up the ranges. But you don't have a subnet calculator on the exam. On the exam, you've got to be able to do this yourself, and you got to be able to understand how to subnet. So I do think the curriculum is excellent, but I think the curriculum has a problem in that it doesn't teach you classful subnetting first. So I teach classful subnetting. Then from here, folks, we're going to pivot and we'll talk about using VLSM or variable length subnet masking. Because right now, if we do this type of subnetting, especially, let's go back to this /25 right here. You notice what if I had a network like this? What if I had a network that was literally this router with a serial connection, which is a point-to-point connection to this router, okay? If I was going to try to use one of these networks on this link right here, I would have 126 addresses when I only need 2 of them. And so we're going to learn about how you can use what's called variable length subnet masking, where you'll use one mask on one link and a different mask on another link. And that's called VLSM. Okay, I expect you to be thoroughly confused at this point. I really do, unless you already understand subnetting. All right. So what I want you to do is I want you to do the 30 subnets and try this 500 subnets. We'll come back next week. We'll go back over this again and we'll go from there. All right. Questions, everybody? This is super, super important. This is, again, the most important thing you're going to learn in CCNA 1 is the most important thing your students are going to learn in CCNA 1. No questions? Wait till you teach this in the classroom at the blank stares you're going to get when you do this, because students go, it's like deer headlights.
A question about net labs.
Okay. Yep.
It seems like whenever I have to do like Wireshark, I don't get the output that's expected. Like if I do it on my laptop, I get like the ICMP network traffic. I can see that on my laptop, but I can't see it in NetLabs.
Okay.
In the PC in NetLabs.
The PC and NetLabs does not show.
I spend a lot of time on it doing the same too.
Okay.
Yeah.
Well, and I will tell you, as long as if you do it on your own PC, that's fine. Are you seeing? Now, let me ask you this: are you selecting the? Are you sure you're selecting the interface in Wireshark?
I do believe so. I never get the 192 address. It stays like the one.
Okay.
The 163.
All right. So I thought that problem had been fixed. All right. I will check on that. Just move past those. That's okay.
And I can't like release and renew the IP addresses as well.
So it's actually just barking at you and not giving IP addresses at all. So
yes.
All right. Yeah, go ahead and move past that. That's okay.
Okay.
I'll work on it and see. If you don't mind, will you send me just what lab it was and I'll check it again.
3710, I think that.
Okay, 3710.
Whichever one.
There's several Wiresharks, but let me see which ones here we got.
And I also had that one, like 4.66, I think.
466.
Whichever, as 4.66 or 4.67, whichever one's in NetLabs.
466 and 3710. Okay, I'll check those. You don't happen to remember what pod you were on, do you?
I think for the first one, I may have been on the last pod, 16.
Pod 16. Okay. All right.
I turned in.
That's fine.
2 for those, so it may be able to show you what pod I was on in that.
Okay. No, it actually doesn't show me the pod. I'll check on this and see.
If we start with the pod and then the pod doesn't give us, because I try several times, but when I use my laptop or my desktop, it's giving me a better chance than I get from the pod.
Yeah, with the Wireshark stuff, it's if that's causing a problem, you're okay. Now the ones where you're doing routers and switches, that's going to work. That will work. So I don't know why again, I'll check this and see what's going on because I know that had been an issue and I thought we'd got it fixed, but I will check it and see what's going on.
Because I spent too more time on it trying to figure out what is going on. Then I tried the laptop and I tried the desktop, my desktop and another laptop, and then I get a better chance than get on. I
think the big thing though is make sure you understand what they're trying to get you to do is see parts of a frame. They just want you to be comfortable inside of Wireshark and using Wireshark and looking at the parts of a frame and what it is and how it works. So if you can use your own laptop to do that, then that'll work too.
Okay.
Okay. But I will definitely, like I said, I will look at this and see if I can figure out what's going on with it.
Yeah, I've let it sit and come back to it and tried to get the correct IP address and it still wouldn't work. So.
Still wouldn't give it to you. Okay. Well, I apologize. I'm sorry. I thought that issue had been fixed, but I guess not. What it's supposed to do is boot a router in the background and provide DHCP. And then you would.
Yeah, it never assigns an IP address.
Never assigns the IP address. Okay. I'll work on that and see what we can figure out what's going on. Apologize for that. Any other questions or issues? Okay, let me stop my recording real quick.